Blackout, stop this attempt to steal power.
Well, if it isn't critical infrastructure, your power is great, but your tech is dated and full of vulnerabilities. You are no match for me and my team, the Infrastructure Destructors. Ha ha ha. Raise the portal. Meet backdoor.
I'd rather not.
He always gets in and stays hidden. Meet single point of failure. She attacks and disrupts at your weakest point. And meet the greatest threat to critical infrastructure, the Squirrel. I'm not sure how he does it, but he's responsible for outages all over the world. That's right, Squirrel. I forgot that we had legacy code as part of our team. He's much older, but he will cause you harm when you least expect it.
The Destructors are no match for the Collective Defense League. I summon two-factor, segmentation, upgrade, and the most trusted superhero, Zero Trust.
Destructors attack!
Way to go, Collective Defenders. The city is safe. Too bad Blackout managed to slip away.
Ha ha ha! You've won now, critical infrastructure and your so-called collective defenders. You will never be able to beat me and my AI once I have it trained, with all your moves and none of your weaknesses. Ha ha ha!
Hi there, it's Ron Gula from Gula Tech Adventures, and this week I'm going to share some of my thoughts on operational technology. I'm going to talk about this from 2 points of view. One, when I was the CEO of Tenable, we had a lot of customers who used the Tenable suite to do assessments and monitoring of, nuclear power plants, large camera systems, things that are not traditional IT systems. But then the second thing, as president of Gula Tech Adventures, we constantly get pitched ways to secure OT technology, right? So I'm going to sort of give my view of the industry to you there. So what is operational technology? Now, if you're a follower of this channel, you probably know a thing or two about that, but basically I define OT as anything that's basically mission critical, that's not like a Windows, Linux, or even a mobile phone. Some people lump mobile phones in there, right? But these are things that control water, that they regulate nuclear power, right? They're things that are very, very much designed to work, in a lights out, uptimes of measured in years, not days or months, that sort of thing. And a lot of times, this all gets lumped into this concept of critical infrastructure. Now, on one hand, if you have an air conditioning system for maybe a shopping center, is that critical infrastructure? Well, yeah, it is. It might not be generating power. It might not be doing cleaning our water and that sort of thing. But if the air conditioning went out at the mall, nobody shops at that mall. It's definitely something that can be affecting the population. So when it comes to cybersecurity, when it comes to data care, and it comes to these types of things, what are we seeing? Well, if I go back to Tenable, if you think about Tenable's main bread and butter, the Nessus vulnerability scanner, it's licensed by being able to talk to IP addresses. Maybe we're logging onto those systems, putting agents on them, scanning them. One of the issues we run into that I see just not only at Tenable, but at other things, is this question of how many OT systems are out there. Now, when I was CEO, if I had a customer who was maybe 100,000 licensed IP address, network, and we said, well, how many of those are OT? It was very small. Maybe it could be 100, it could be 1,000. It was a very small percentage of that. It certainly wasn't enough to maybe charge more for those things, even though we had dedicated, SCADA and ICS assessments, built into Nessus and whatnot. But today, the number is almost 50-50. So over the last 10 years or so, if you have an organization that's got a lot of OT devices, it might rival the number of Windows computers or even exceed that, right? So this is a big change that I've seen. Now, of course, there's variations from industry to industry and so on. But the second thing that I learned from Tenable dealing with these OT systems is that they can be fairly brittle. Now, we're going to talk about code quality here and secure by design and stuff like that, but basically, you could ping one of these systems, you could do a port scan on one of these systems, let alone a vulnerability audit, and you might take it offline. And this is not just a fact of doing this with something like Nessus, like any system out there. Like I've talked to a lot of operators, and they don't want to do discovery on their IT management system, just a simple SNMP sweep or polling on the network to see what's out there, because some of these devices, their network stacks are so brittle that they would fall over. And if that's the thing that's opening and closing the floodgates, so to speak, it's there. So while at Tenable we had developed this technology called the passive vulnerability scanner. Now it's called the Nessus Network Monitor, but the basic idea is to look at the network traffic, and as all the packets come in, try to conclude the same sort of information about assets and vulnerabilities as you would with a vulnerability scanner, right? If I see a web client go into a web server and you can read the banner, well, that's just as good as doing a banner check on a from a vulnerability scan or an Nmap or that sort of thing. So the passive scanner was really, really something popular with OT networks, and also because it was continuous. A lot of times these OT systems, if somebody comes in and plugs in a laptop for just a brief little bit, you're not going to get that at the next vulnerability scan. So you have to do this from a continuous point of view. Now, that really hasn't changed. If you looked at all the new sort of vendors that are out there that do asset discovery, Exonius, Tenable, of course, all the different kind of folks that are out there, they all have a passive component, and they will enrich that passive component with third-party data, perhaps from the switch, perhaps from their EDR vendors, perhaps from those sorts of things. All right, so now as president of Google Tech Adventures, what sort of things are we seeing that people come to us for funding to secure operational technology? I'm going to start from the inside out. So let's go from the actual devices themselves. How do you fix the source code on that? Well, it turns out that if you can do a CI/CD pipeline for source code management, for security, for containers, Kubernetes, that sort of things, that's actually very similar to producing an embedded system, right? A lot of these things are core Linux. There's limited services on there, and you have to test these things. Now, our investment in this space is StartLeft Security. There's a lot of companies that are doing cybersecurity source code auditing, and StartLeft's ability to kind of help coders gamify, how they're programming and what they're doing, and reminding them at the best time in the software lifecycle, how to fix their code and make their code secure is really what they're doing. But regardless, right, if you're a customer already and you've got these OT things deployed, somebody doing development up the road fixing their code, unless you can patch that system, it's really tough. And one of the things we found with OT systems is there's so many of these legacy systems that are out there that maybe you can't get the patch legally from your vendor. Maybe you can't even apply the patch because you've got to, fly to 100 sites across the country and, take the system offline, put a USB stick in, that sort of thing. And anybody who's got like a home TV, if your home TV is connected to the internet and you look at updates, modern TVs right now, you can do live over-the-air updates, but a lot of these systems don't even have internet connectivity, so it's hard to get those things in there. So because of that, getting patches to these systems is really, really difficult. So we see sort of all sorts of pitches to sort of segment these systems. Now, the easiest way to segment these OT systems is to simply air gap them. Now, if you saw the Enclave video, I'm not talking about cryptographically air gapping these things. I'm talking about literally air gapping. And I have a lot of friends who are CISOs, and I'll ask them, how they're doing it. And a lot of times they'll jokingly say, we use the ONOFF method, right? We call Larry on his walkie-talkie, and if we have to make a change, they're doing it at some physical plant on the other side of those networks. Now, a lot of times, these same systems, you really can't do cryptographic segmentation. And if you saw the Enclave video, I was talking about taking your Windows computers, your Linux computers, putting a captive VPN on that, and letting them only talk to other computers. Well, if you have an OT device, you don't have access to that software. You can't load code onto that, right? So a lot of times we get pitched companies who want to do some sort of segmentation based on routing. And the basic idea is where you're going to take your OT devices, and between them and the router, you're going to add another router. And that router is going to encrypt all their traffic to however you want to get back to your network management systems. And a lot of times what these look like, they look like a zero trust system. But if you've deployed, Zscaler or our Enclave investment, you're installing agents onto computers. A lot of times there's not forced gateways and that sort of thing. This is sort of a captive gateway, I like to call it, where all of the packets that are coming in and out of these OT devices are going to some sort of device. It might look like a firewall, it might look like a router, but it's going to encrypt all that and send it only to the other side, wherever your network management things are. Now, that type of segmentation, it works really well. You really have to make sure that your OT devices are not addressable. Like, in other words, if all you're going to your OT devices and changing the route, but the old router is still there, there's still an attack path to get to these things. And I've seen a lot of issues with that. Now, another thing you can do is you can actually try to do something called a data diode. Now, we have an investment in a company called Fend. This is a one-way data diode. And basically what that means, if you think about a network connection, it only goes one way. So let's think about somebody like Target, right? Target had their entire network compromised through their heating and air conditioning system. Well, if all you're doing is getting temperature out of your places, and if the temperature goes out of whack, again, you're going to call Larry or Joanne or whoever the person is on the other side of that is going to physically do something for you. If all you have to do is read temperature, boy, that's a great one-way system. If I just want to read a variable from whatever it is I want to monitor, it could be a bomb shelter, right? It could be a gasoline station. If I'm just reading and I don't have a reverse attack path, these one-way data diodes are really good. There's a wide variety of vendors out there. We really like Fend because it's easy to use, and it's a very, very low cost compared to the other things. But again, you don't have that backwards attack path. You can connect to the internet and not be attacked by the internet, which is a really, really cool thing. Now, the last form of segmentation I want to talk about is where you take your existing infrastructure and you basically modify it. Now, if you think about an OT infrastructure that's connected to the internet, you're going to have your traditional things. You're going to have your switches, you might have a firewall, you might have routers. And if these things are in hardened sort of offline areas, they will be, they might look different. They're going to be, because they want to survive and not be touched for a long time. But you're still, from a logical network diagram, you still have those kind of things. Well, one of the things you can do when you want to segment those things is maybe you're going to add a bunch of firewalls. And a lot of OT people are like, look, I've had my network up for 20 years, 15 years. They might love Palo Alto, they might love Cisco, they might love Fortinet, but they're not going to come in and do a massive change at these places. Maybe there's no rack space, maybe there's no power, maybe there's no bodies to go to all these sites. So what can you do if you actually just have your existing infrastructure? Well, there are companies out there that can take your existing infrastructure and basically manage it better. There's a company we like called Elicity. We're not invested in it, but it's a pretty neat trick. What they do is they look at all your flow coming out of your OT networks, and then they can actually go into your switches and put access controls on that. Now, if you're familiar with firewall technology and switching technology, there's a big difference between a filter, an IP filter, and a stateful firewall. Well, it turns out in OT, if you have like 1,000 cameras and they only need to talk to maybe your management system, it's actually pretty easy to come in and do all your IP filtering at the switch level, and prove that you've done that and save yourself from deploying all of these firewalls that are out there. And that can be a budgetary savings. And I'll go back to the Wizard of Oz video we did about Ira Winkler's talk. You're using stuff you already have, and as much as this new tech is cutting edge, taking new tech and applying it to your old tech might be a really good solution for an OT system. Now, the last thing, of course, we got to talk about is that these OT networks, there is another sort of model to secure them, and that's to monitor them. And if you look at Clarity, look at Dragos, and we are indirectly invested in Dragos. And I'm always going to be a big fan of any company based in Maryland, doing cybersecurity work. But for the most part, bringing some sort of continuous monitoring for attacks, doing threat hunting, into that OT network is a very, very important thing. And because of that, we've actually got some decent vendors out there that can look for attacks that are living off the land inside those networks that are hard to find. We've seen backdoors, we've seen China try to do things, try to put stuff into our infrastructure. There's been a lot of news about that sort of stuff. It's a whole different world than Windows and Linux attacks, Apple attacks, that sort of thing. So I highly recommend that people work with either one of those vendors where you can get that service as a SaaS or an MDR who's basically focused on that sort of market. So now, from Gula Tech Adventures' point of view, we do think this is a market that's really important. I want to give DHS and CISA a lot of credit for secure by design. It's trying to get the code that's shipped as secure as possible. It's really, really important. It's why we invested in Start Left Security. It's why we try to tell people that, look, if you're coding, you might not think your code's important, but, it could be a game to somebody, it could be critical infrastructure to somebody else. We've got to make sure the coders are doing that. But then whatever you have out in the field, boy, that's got to be secure too, whether it's a 30-year-old PLC controlling the flow of water or putting fluoride in the water for us, or it's the latest thing that you just bought that you have patching and that sort of thing. So I hope everybody found this video interesting. I hope you enjoyed the 3D visualizations and also the little superhero movie we put at the end of this. If you found this interesting, give us a like, connect with me on LinkedIn, and don't forget to subscribe to this channel. I hope everybody has a great week. I'm Ron Gula. Have a great day.
And that brings us to budget item number 32. Two-factor requests some 2025 R&D funds for her authentication lab to research becoming multi-factor instead of two-factor.
Approved.
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 Thank you. With the increasing attacks on critical infrastructure, multi-factor offers more protection.
Hey, critical infrastructure! Meet my new friend AI. He knows all your moves and has none of your weaknesses.
You again?
The Collective Defense League uses the NIST cybersecurity framework to compensate for all of the weaknesses in critical infrastructure.
Yes. But compensating for vulnerabilities and weaknesses in critical infrastructure is hard and monotonous. And with just one slip up, my AI will be able to attack.
Blackout. To counter your AI threat, we've adopted a new team member who will one day become our most powerful member, DataCare.
We are no match for DataCare. AI back to the secret lab.